Okay, this question here is it's an explanation question where you're asked to explain why air has to be released continuously, okay, and then so that it can the airbag and the object can rise at constant speed, right? So these are the key words of this question here. Rising at constant speed means acceleration equals to zero. Okay, acceleration equals zero, and why air is released from inside? Basically, the lifting bag and object can move up is because of the upthrust, and the total weight is less than the upthrust. So initially, maybe you want to lift up the object, and from the air of seabed, your upthrust may be a little bit greater than mg. So once you start moving, you want to adjust it until it's more or less equal weight at all times. Okay, so once you start moving, you want this upthrust to be equal to the weight. Now the weight is constant here. This is constant. Now, now this is constant means the upthrust must also remain constant, right? In order for it to move at a constant speed. So this upthrust depends on the volume, which is the density of water, and the volume of the mostly the airbag times g. Okay, so this must remain constant. The problem is if you don't do anything, the volume will not remain constant. Okay, why is that so? Right, if you take this whole thing in the seabed here, you take this thing at somewhere at the bottom here. So somewhere at the bottom, how much volume here, this volume here depends on the external pressure and internal pressure, the inside pressure and outside pressure. So what happens is the inside pressure is greater than outside pressure. um, so that's why you can occupy a certain volume. um, the thing is the outside pressure is pressure water at the depth, which is rho g h. H is the depth below the surface, the depth of water below the surface. So outside is, say this is the seawater outside, so h is something like that here. Okay, so as the balloon as a lifting bag goes up, the h becomes smaller and smaller. As a lifting bag rise up from the bottom, the h becomes smaller and smaller. So as a balloon as a lifting bag rises, the h decreases. H decreases means that the external pressure decreases. Means that the volume will increase. The volume will increase. So the volume will increase means that the upthrust will increase. So the upthrust will increase. It means that there will be an acceleration, right? A will be greater than zero. It will not be zero. So, but you want A to be zero. So, in order for the acceleration to be zero, you must make sure that you, as as the lifting bag rises from the seabed, the external pressure decreases. You also must decrease the inside pressure. So the air has to be released so that the volume stays the same throughout. Okay, so air is released so that uh, released to maintain a constant volume. To maintain a constant volume. Okay, when the volume is constant, then upthrust will be constant, and then you will have acceleration equal to zero. Okay, so that's the first part of the question, the explanation part. The second part of the question is what happens if we suddenly put in a volume of air into this air lifting bag, and then what is the initial acceleration? So to solve this problem, we just basically apply Newton's second law, F equals ma, resultant force, net force equals to mass times acceleration. So then net force is basically made of two terms, the upthrust, the total upthrust minus the total weight equals to the total mass times acceleration. Okay. Now, well, the total weight is actually made of the mass of the total mass is mass of the cannon, which is 800 plus um, the mass of the air and airbag and all that, but mostly is due to the cannon. So you can more or less plus a small amount here, which is very small. You can take this to be 800 kg effectively. Okay, anyway, you're not given the density of air and the airbag and all that. So you can take this 800 kg to be more or less equal to the total. Okay, this can be taken as 800 times A. This can be total mass is 800 times G will give you the total weight. So the total upthrust is actually density of water outside times the volume of the total volume. The total volume is the volume of the bag plus the volume of the cannon. The cannon also has a volume. G. The cannon also has a volume. There's a density. You are given the mass and the density, so you can calculate the volume. Okay, so the density. Let's put in the numbers. So this is 1050. Volume of the airbag is 0.7. The volume of the cannon is actually 800 divided by 8000. Okay, the mass divided by the density give you the volume. It is 9.81. Then minus 800 times 9.81, then equals to 800 A. When you put you work out all this, you should be able to get value of 0.49 meter per second square. Okay, that's all for this question here.